Hey folks, we're back into chapter 3 on bonds, and we're in section 3-2. We have a few new concepts. And the first one we have to look at here is a graph. This is the graph that graphs the yield to maturity for 10-year treasury bonds every year for the last 54 years. You can think of a yield to maturity in a bond as an internal rate of return on the bond, right? It's got a price that it's trading at. You know the cash flows it's going to generate, which are the coupon payments. You know the face value you're going to get in the end. So you can kind of calculate what this treasury bond is going to yield to you, what the average compound annual rate of return is going to be on the investment. That's yield to maturity. So it's also what we call the discount rate, right, for bonds. And this graph here plots the yield to maturity for 10-year bonds over a 54-year period, so you can see what happened. Now, if you look in the year 1981, that was the year that if you were investing in 10-year treasury bonds, you were making money hand over fist. 15.8% return. That's better than the average return on the stock market. Contrast that with the year 2020, where the low yield to maturity on 10-year treasury bonds reached as low as 0.5%. All right, so we got to ask ourselves, why in some years is the yield to maturity on 10-year treasury bonds so much higher than in other years? Well, here's what happened. In the 1970s, late 70s, there was major inflation in this country. Inflation is rising prices for goods and services. And unfortunately, it's very, very damaging to an economy and has to, if possible, be brought down. Inflation has to be shut down. Normally, inflation should run around 1% to 3% for a country in good standing, but in the 1970s, inflation was out of control. It was into the double digits. And the way that the federal government can combat inflation is to raise interest rates. I mean, the government's the biggest borrower. They establish interest rates on short-term borrowing, which affects long-term borrowing. So the federal government can manipulate interest rates in this country across the board, because everything is built off the risk-free rate, which are treasuries. So the government decided to combat inflation in 1979. And what it did was it raised interest rates. And you can see this in the 10-year treasury bond. Once interest rates started going up to combat inflation, interest rates on all government securities and all securities went up to astronomical levels. But this was necessary. How does raising interest rates kind of across the board in the economy stop inflation? Well, it slows down the economy. And if it slows down the economy, there's less demand from people, and there's less demand for businesses, for goods, for services, for labor. And so when you've got very little demand but a good amount of supply of these things, then prices fall, right? And that was the idea here. That's how they're going to combat inflation. Well, it worked, and inflation came down, and it steadily decreased, as you can see. Inflation came down inflation came down after that, and interest rates steadily decreased as the federal government and the world became comfortable with the fact that inflation had been mitigated and wasn't really going to rear its ugly head again in a material way. Right? In fact, if you talked to someone 2 years ago, if we'd have inflation again, I think the answer would have been probably not. We finally got a Federal Reserve and a Treasury Department that understands how to do this, since we haven't seen high inflation rates since the 1980s, late 70s, until it got combated in the early 80s. So we're good to go. But obviously that's not true, because as you can see, if you look in the year 2020 and now to 2022, which is kind of the end of this graph, you can see rising interest rates again. Why is that? Because we're finally dealing with inflation for the first time in a long time. We've had inflation rates at 9%, nearly 10% here in this country in the past year, and that's not good. What's caused that has been supply chain disruptions caused by the COVID lockdowns around the world, If you got a decreased supply of goods and services and you still have the same pent-up demand in society, then that raises prices for goods and services. Likewise, COVID caused a lot of people to stay home and not work. And if there aren't that many people in the labor force, but there's still the need to fill those jobs out there, then wages increase. And all that stuff is causing a rise of inflation. Well, the government finally decided to combat this a few months back and has been quickly raising interest rates again. From a low of 0.5%, now it looks upwards of 4%, or coming up to 4% now on average for the 10-year treasuries. And they're trying to raise interest rates across the board to combat this inflation and get it under control. Because the economy cannot survive with high levels of inflation. All right, this is a different curve. This is a very important curve. This curve is referenced all the time in financial news. It is a very important curve. It's called the yield curve. And this plots treasury yields as a function of time to maturity. All right, so this graph is produced literally every day. A new one of these graphs is produced every day. This is a snapshot in time. This happens to be a particular snapshot from the year 2013, as recorded in Encyclopedia Britannica, of treasury yields as a function of time to maturity. So what I mean to say is, if you look down on the x-axis right here, what you have is the length of maturity of a bond. So maybe you have a 5-year bond, you might have as high as a 30-year bond. It seems to go a little past a 30-year bond here. And then a 30-year bond is paying a higher yield to maturity, a higher internal rate of return than, say, a 5-year bond, right? If you look at this, it looks like about a 2-year bond is paying under 1% in 2013, but the 30-year bond looked like it was paying about 6%. This shape, this concave down, increasing shape, is the normal shape for a treasury yield curve, for the yield curve. And it makes intuitive sense, right? If you're investing in a longer-term bond, there's more time, therefore more risk that things will go badly in some sense that could jeopardize your investment, whatever that may be. So the longer you're invested in something, the more risk there is, a variety of risks that are greater. Time offers more opportunity for risks to come to fruition. So you'd expect to be paid a higher rate of return or a higher yield to maturity, which is really what you're making on a bond, for the increased risk that has to do with the length of the duration of the bond. So once again, when you look at this graph, it is a snapshot in time. Tomorrow's yield curve is not today's yield curve. And this was a snapshot from the year 2013, and it's plotting the time to maturity of a bond, and it's yield. A yield is a function of time to maturity. Very important curve. This is the normal shape of a yield curve. This is what we call an inverted yield curve. This rarely happens, but when it happens, it is one of the greatest predictors of an economic recession that we know of. It is not an intuitive curve, is it? Nope. This yield curve has short-term bonds, like 2-year bonds, getting a much higher internal rate of return, a much higher yield than, say, the 30-year bond. Does that make sense to you? Why in the world are you going to be paid so much more money, right? Getting such a better return on a short-term bond, a 2-year bond, than you want a 30. That doesn't make much sense. And this happens typically before a recession occurs. It's called an inverted yield curve. So when the yield curve inverts, short-term bonds are offering a better rate of return than long-term bonds. Why should that be? Why should this unusual situation occur that often precedes an economic downturn? Well, what's happening is investors are predicting, when you see this inverted yield curve that's taking place, again, at some point in time, investors are predicting that long-term interest rates will fall in response to a slowing economy, right? When the economy slows, eventually the government has to prime the pump, has to get the economy going again. Because you don't want a slow economy, you don't want an economy in recession. So in that case, the government needs to get things moving again. The way it does that is by lowering interest rates, right? The nation will adopt the federal government will adopt a expansionary fiscal policy to stimulate the economy. How does lowering interest rates stimulate the economy? Well, it makes the cost of borrowing a lot cheaper. Well, if the cost of borrowing is a lot cheaper, then there's a lot more businesses that are willing to go out and borrow a lot of money and try to finance NPV positive projects. And it's easier to finance a NPV positive project when you're paying a whole lot less to finance that project. This is what the government does. When the economy slows down, it lowers interest rates. Well, this is kind of a point in time before a recession where investors are predicting that's just what the government's going to do. It's going to lower interest rates across the board. And so the long-term interest rates now are much weaker than the very short-term interest rates because bad things are coming in the future. Right? That's the idea here. All right, so I pulled up the yield curve from 9/12/2022. It's a very recent yield curve, isn't it? And I want you to look at the shape of it. It is clearly an inverted yield curve. What does that tell you? It tells you if the history is a teller of the future, we're on the precipice of an economic recession or we're already in an economic recession. And this is bad news. Well, the question is this recession a typical recession? And the answer is, on some hand, every recession is very similar. On the other hand, there are differences. And the differences here, it's kind of a man-made recession. Isn't it? We seriously curtailed the supplies of goods and services and slowed down the world economy in response to a pandemic. So it was a choice, right? It was a choice. It wasn't just kind of the natural ebb and flow of the economy. It was a choice in response to a global pandemic. And now there's a choice being made by at least the U.S. federal government and other federal governments to raise interest rates in response to the inflation that's arising from the choices we made to stop business in response to COVID-19. So I think everybody in some sense expected a recession. But we also knew we created it of our own accord. So it is hard to judge whether or not we should all be panic-stricken at this point. And we kind of knew it was coming and it's baked into our expectations. Nevertheless, we have an inverted yield curve. This has been a harbinger of bad things at all points in history up to today. And this, again, is a snapshot in time from 9/12/2022. It is the yield curve for treasuries. Looks like it's recording everything from 1 month to 30 years here. Those are times to maturity, right, of a bond, length of the tenor of a bond. If you're having trouble seeing why this yield curve is inverted, if you think it looks like a normal yield curve, the reason is your eyes are deceiving you. If you look at what looks like a normal upward trending yield curve, an increasing yield curve, that's from 1 month to 1 year. But if you look at the heartbeat of the yield curve, which is from 1 year all the way to 10 years, you see that the curve has a decreasing slope. That's the inversion I'm talking about. Also, if you look from 20 years to 30 years, you see a sharply decreasing slope. That's odd. Okay, that is odd. So just ignoring the very short term sub 1 year yields, you got an inverted yield curve, and I hope you can see that. All right, here's a third curve, not to be mistaken for the first two. This curve is graphing bond prices as a function of interest rates. Okay. This is very important. As interest rates rise generally, yield to maturity on bonds must also increase as well. If the government causes interest rates to rise to, say, combat inflation, all interest rates for all lending, borrowing are going to increase across the board. They move not in lockstep, but they move together in the same direction. If interest rates rise, yield to maturities, which are really the effective interest rate, the internal rate of return on bonds, is going to increase as well. Well, that increase may occur in bonds by increasing the coupon rate for new bonds. Certainly, if you increase the coupon rate on new bonds, that's going to also increase the yield to maturity on those bonds. But what about existing bonds? Bonds already in circulation that are trading through the network of bond dealers or sometimes on exchanges. What about these? The yield to maturity of things has to increase to match like bonds. How can that happen? You cannot change the coupon rate on an existing bond. That's established from the beginning. It's a fixed rate in the contract. So for an existing bond already in circulation, a change in the coupon rate is not possible. So bond prices must decrease in order to increase the yield to maturity on that bond. Right? You have to think about the bond math. What happens when you increase a discount rate? What happens to the present value when you increase a discount rate? It causes present value to go down. So what happens if you increase the yield to maturity, which is the discount rate on the bond? What's going to happen to the price of the bond, which is the present value of the bond? It's going to go down. You see that? So if interest rates rise, the yield to maturity on bonds has to also rise. For new bonds, you can just increase the coupon rate to get the yield to maturity up. But on existing bonds that are out there in circulation, which we're talking in the billions, right? How's that happen? These yield to maturities have to increase. Well, that happens by the price of the bonds that are trading going down. That's the only way it can occur. Important. So here's the fundamental question we have to ask in this section. What will be affected more by a change in interest rates? A short-term to maturity bond or a long-term to maturity bond, right? Is it going to be what's more affected by increasing interest rates? Is it going to be a 3-year bond or a 30-year bond? What do you think the answer to that question is? You can answer this question. You definitely know. You have the tools if you think about it. You know that a rise in an interest rate, including yield to maturity of a bond, causes a decrease in the price of the bond. We just talked about that. And you know and understand discounted cash flow math and bond math. So what do you say the answer to the question is? What will be affected more by a change in interest rate? A bond with a long term to maturity or a bond with a short term to maturity? What do you think? The answer? The price of a bond with a long time until maturity will be affected much more than the price of a bond with a short time until maturity because, think about this, say a 10-year discount factor has a much bigger impact on cash flows than a 3-year discount factor when computing present value. Isn't that true? Right, if you take cash from year one, that 1-year discount factor, it takes a little bit off the top, but not much when you're taking it back to year 0. But if you take year 10 cash flow, and you apply a discount factor, there's a major haircut on that thing, right, on those present value cash flows. That's the idea. The further out you go, the more that compounding factor, the compounding interest, the more the discount factor has an impact on the price of the bond. So clearly, long-term maturity bonds are going to be much more affected by rising interest rates or falling interest rates than short-term bonds. Okay, and now we've reached the heart of this section. We're going to extend this idea. Let's ask ourselves this question. Are the two bonds listed here, which have the same time to maturity, they both mature in 2032, are they equally impacted by changing interest rates? Or is one more affected by changing interest rates than the other? Right? We know longer term to maturity bonds will be more affected by change in the discount rate, change in the interest rate, change in yield to maturity. But what about two bonds that have the same exact yield to mature, same exact time to maturity? These guys would both mature, say, in 10 years. One has a coupon rate of 7% and the other one have a coupon rate of 2%. Will they be differently affected by changing interest rates? And the answer is the bond paying the 7% coupon rate is affected less. And here's why. Because more of the total cash inflows, that is the coupon payments plus the face value, happen earlier in the life of the bond and are therefore less affected by those later, stronger discount factors. And you can think about it in reverse, right? The bond paying the 2% coupon rate is affected more because of more of the total inflows, that is more of the coupon payments plus the face values, happen later in the life of the bond, and therefore are more affected by those much more powerful discount factors. Now, this idea is so important, it gets its own name and calculation. It's really the heartbeat of Section 3-2. A bond's time to maturity adjusted for the relative size of the coupon payments is called duration. Duration is the heartbeat of 3.2. Every person who understands bond math must calculate the duration of a bond. Rather than getting into it in any more depth at this point, let's go and do an example and then we'll go into more depth. All right, the date is 9/16/22. A corporation issues a $1,000 corporate bond paying a 9% coupon and maturing in 9/16/29. It's a 7-year bond. Comparable bonds are producing a yield to maturity of 4%. What is the fair purchase price of this bond? And that you already know how to do, so I'm going to just get you warmed up with that. And then the big question, what is the duration of this bond? Let's see how we calculate this. You recognize this. We set this up in class. On the left here, I put the basic information, like the type of corporate bond, size, $1,000 US, maturity 7 years, coupon rate 9%, and the yield to maturity 4%. So let's calculate the price. How do I do that? You know how to do that. You set it up in Excel, and that's what I did. I just copied it over here for you to see. So if you want to get the present value of the cash flows, you go ahead and do that, and then from there you determine the present value of the bond, which is the bond price. And so here you go. The bond price is $1,300.10. Let's think about this. Does that make sense? The size of the bond was $1,000. It's paying a very high coupon rate of 9%. Yield to maturity out there, which is the expected internal rate of return on the bond, is not so high. It's 4%. That's about what it is right now, right? If you tried to buy one of these bonds, so you'd expect that this price on this bond has to be a lot higher than the face value of $1,000, because you're getting way too much coupon compared to the yield you should be getting of the bond. So the price goes up to meet that necessary lower yield. All right, now let's talk duration, which is the thing we're trying to get at here. How does one calculate duration? Here's how you do it. See those present value of cash flows? We're going to take each one of them, say the 86.54 or the 83.21. We're going to take one of those guys. We're going to divide it by the price of the bond. That is the present value of the bond. We calculated $1,300.10. Then we're going to take that ratio and we're going to multiply it times T, which is the year. So for the $86.54, we're going to divide that by the $1,300.10 and then multiply it times year 1. So multiply times 1. But if you say go to year 7, we're going to take that $828.31 divided by the price of the bond, $1,300.10. And then we're going to multiply that times 7 because we're in year 7. That's what T is representing here. And you can see that the largest contributor to this thing called duration is going to be in year 7 because that's where you got the biggest cash flow drop, which is the redemption of the bond that's at face value. Well, if you total up all the present value of the cash flows divided by the present value of the bond times T for each of the years, you get a total of 5.69 years, which is the duration of this bond. That is the duration of the bond. Notice duration is always going to be less than or equal to the maturity of the bond. If you had a bond that had like a 0% coupon rate, then its maturity will be the same as its duration. But most bonds pay a coupon, a fixed coupon rate. And for those bonds, your duration is going to be less than your maturity. Why is that? Because you're not getting all your money in year 7. Therefore, you're not having really all the risk of having the whole cash flows of the bond out there for 7 years. No, you're starting to get some of the inflows in earlier, in year 1, 2, 3, 4, 5, 6, in fact. And that takes a little bit of weight off of that long-term risk, making the risk a little bit shorter. How do we quantify that? We say, this bond is more like a 5.69-year bond. Yes, it has a time to maturity of 7 years. Yes, it'll finally be paid out. Its redemption value, its face value in year 7. But really, it's kind of the risk equivalent of a 5.69-year bond. If there were no coupon payments and you were just getting paid back at the end of 5.69 years, that's what duration is. That's how you calculate it. Now, you need to be able to calculate duration. So just to look at this again, slightly different. Same bond, the date is 9/16/22, and a corporation, again, is issuing a $1,000 corporate bond maturing 9/16/29. Same yield to maturity, 4%. This time, though, what's the coupon rate? 0%, right? There's literally no coupon payments. There's just that final redemption at the end of the $1,000 face value. So what's the fair purchase price of the bond now? What's its duration? Well, again, we know how to calculate this, right? Once again, the coupon rate here is 0%, and you can see, since there's no coupon inflows, no coupon payments, the only payment you're going to get is that $1,000 in face value redeemed in year 7. And if we discount that at the 7-year discount factor at a 4% yield to maturity, we're talking about a $759.92 present value or bond price. Now let's calculate the duration. Before we do, though, tell me, what do you think the duration will be on this 0% coupon bond? The answer is the duration should be 7 years. Let me just reiterate this. This should say 0% corporate bond, and it should have a coupon rate of 0%. I'm sorry, the slide got a little messed up. As you can see, though, for the 0% coupon bond, the duration is 7 years, exactly in line with the maturity, because there are no cash flows earlier on, no coupon payments to kind of take some of the weight off of that long-term risk. The risk literally lasts 7 years because you're not getting any inflows until year 7 or the end of year 7, so your duration is 7 years, just like your time to maturity. All right, so let's revisit this idea of duration. You can think of duration as time for maturity adjusted for timing of cash flows. But please, never call duration time to maturity. They are different things. Now, if two bonds have the same time to maturity, as we've already seen, they can have different durations, depending on when those coupon payments, those cash flows are coming in, and how heavily. Now, the question, of course, on your mind is, why do we care about duration? The answer is this: duration is a way to measure a bond price's sensitivity to changes in interest rates. Right now, the government is raising interest rates in response to inflation. Let's say you're holding a bunch of bonds. What's that going to do to bond prices? The only way you're going to know is to know the duration of the bonds that you're trying to analyze. It's not enough just to know time to maturity. You need to know the duration, because that's the true level of price sensitivity to changes in interest rates. The longer the duration of a bond, the more sensitive the bond price will be to changes in interest rates. We've already seen that. The longer the duration of the bond, the more interest rate risk the bond carries. So you need to ask yourself, well, how do we measure duration again? What is duration measured in? It's measured in years, just like time to maturity. Right? We're thinking of it as kind of a modified time to maturity, accounting for timing and size of cash flows. So duration is also going to be measured in years. One last idea: when you hear on the news discussion of duration, oftentimes you're hearing not duration, but modified duration. You should know these both. Another way to measure bond prices' sensitivity to changes in interest rates is modified duration, which also goes by the term volatility. And the calculation for modified duration or volatility is just duration divided by 1 plus the yield to maturity. So modified duration is not going to be measured in years. Can you discern what it's going to be measured in? Modified duration is going to be measured in percentage change. Modified duration measures the percentage change in a bond price for a 1 percentage point or 100 basis point change in yield. What do I mean by that? There's a difference in the use of language here, right? I'm saying percentage change for the bond price. I'm saying 1 percentage point change in yield. Those are different. When I say 1 percentage point change in yield, I mean the difference between a 3% yield and a 4% yield. A difference between 3% interest rates out there and 4% interest rates out there. If you get a 100 basis point uptick in the average yield to maturity of a particular bond, you get a 1 percentage point increase in the internal rate of return for that bond. Then it will have this percentage change on the bond price. Okay, so try to keep that straight in your brain. Listen, I know it's a lot to handle. Duration is super important. So please, if you have to review this whole presentation again, do it. You want to get under your belt. It is as necessary as being able to calculate a price or a yield to maturity on a bond to understand this concept. All right, have a good night.